In today's lesson, DS04, we're going to be talking about the accuracy of measurement instruments like rulers and syringes, things like that, that you can use to measure distance or fluid or capacity, and how to choose the right one to be more accurate or be more precise. This connects to Common Core strand N-Q.A.3, which is choose a level of accuracy appropriate to limitations on measurement when reporting quantities. Important here is the word limitations. For our opening, the question is a little bit of a story. One of your friends is on a family vacation to the Grand Canyon over spring break. Your friend has a younger brother named Jeremiah who is learning about both the metric and customary systems of measurement and is excited by all the different things he can measure. He's a little kid. He sees something. He wants to measure it. Jeremiah records them all in a spiral-bound notebook, and he writes, "Stuff I saw and want to measure." He sees bugs, ant legs, size and weight of pebbles and rocks, distance of the walking trail, distance from New Orleans, which must be his hometown, and height of a tree, height of a mountain. His list goes on. Although Jeremiah is super excited to measure stuff with a paper centimeter ruler that he got when he took the state test, they look like this. I wonder if he took it, or if he was given it. I wonder if he asked permission. It's always better to ask permission. Anyway, he meets a scientist named Dr. Funkiller on a hike one day who is super smart. The doctor says that although it is a joy to measure objects and collect data, there are times when certain measurement devices, like Jeremiah's ruler, are not appropriate. What might Dr. Funkiller mean? Hint, talk about the ruler versus the list. So right now, let's kind of take a look at this ruler. I see that it is measuring, I think that this is inches, although it doesn't say. And then I know usually on those rulers that you get for state tests, it's like one side has inches, the other side has centimeters. And I think I'm going to confirm this. I know that centimeters takes about 2.5 to equal 1 inch. And this is about 2.5 centimeters for 1 inch. So what the doctor is saying is sometimes this ruler that Jeremiah is working with isn't going to be a good ruler to use, one that's not going to be appropriate. Let's look at Jeremiah's list of things he's measuring. He wants to measure bugs and ant legs. These are all small things. So that ruler might actually be a good thing for these two. He wants to measure the distance of the walking trail. Well, that would mean he would have to put that little ruler down probably hundreds and hundreds of times. Distance from New Orleans, Grand Canyon and New Orleans is going to be hundreds of miles for sure. The size and weight. Well, he can't use that ruler to measure the weight, but he could use that ruler to measure the size of pebbles and rocks. So I think it looks like 1, 2, 3. The first 3 things here, you would use that ruler. Height of a tree, I wouldn't use that ruler because unless it was a tiny, tiny, tiny little tree, a bonsai tree, it wouldn't be a good thing. And height of a mountain, definitely not. You would need to spend your life basically measuring that. So I think what Dr. Funkiller is saying is sometimes rulers are going to be good to measure certain things and bad for other things. Even though the ruler could be perfectly fine in one scenario, it's not going to be great for others. That's what today's lesson is about. So for our vocabulary today, we're going to talk about these 4 words: precision, accuracy, appropriate unit, and measurement limitation. This is one set of words. This is one as well. Although precision and accuracy are different, they are different things, quite different actually. Today we're going to group them into the same category and generally talk about how precision and accuracy are talking about the closeness. Meaning like, the closer you are to being exactly correct, so exact, the more precise and accurate you are. Typically with accuracy, you're talking about a bullseye, and same with precision, whether or not like it's exact. Appropriate unit, this connects to a previous lesson where it means instead of measuring the weight of an elephant with something like a kilogram, we're going to measure with something like a ton. It's more appropriate to talk about how many tons an elephant weighs than a kilogram or an ounce. And then measurement limitations, what this is really talking about is you can only ever be as accurate and precise as the measurement instrument. When I say instrument, I'm talking about something like a ruler or a beaker. So if I'm talking about a ruler that has 1/2 inches, well, the most accurate I can be is to the 1/2 inch. I wouldn't be able to say something like, oh, it's 4.725 inches. Nope, I can't talk about that. The closest I could be is it's either 4.5 inches or it is 5 inches. That's the most accurate I could be because this is split into halves. I don't have any little tick marks that breaks it up any closer. And if I wanted that, I would have to get another ruler. Okay, now it's time to build some skills. Accuracy and precision, we know, have to do with closeness. You can write this down. Or exactness. The smaller the unit, this will make sense soon, the more accurate. So an inch is more accurate than a foot, and a foot is more accurate than a yard. A centimeter is more accurate than an inch because it is smaller. Limitations on measurements has to do with a centimeter ruler only gets me down to the centimeter, and an inch ruler only gets me down to the inch. So if this is 1 inch, the only way that I can really accurately talk about whatever I'm measuring is to the inch. And if this was to the centimeter, the only way I can really accurately talk about things is to the centimeter. I shouldn't be talking about millimeters. Here I shouldn't be talking about third inches or 1/2 inches. Interpreting measurement devices, that's kind of all contained here. And you're going to, when I say interpret, mean look at and think about and decide what units you're talking about. One way to think about this lesson is using the right scale or using the right unit. This here, it's a picture of a truck, a big truck that you might have seen one of these weigh station signs, or a sign like all trucks over 20,000 something next right. They're gonna get you if you don't pull over. They're gonna get your license plate. You wouldn't measure the weight of a person with this. I don't even know that the scale would register it. And my guess is these units would be in tons, maybe even rounded to just the ton or 5.5 tons. But it would not tell you how many pounds, it wouldn't tell you how many ounces or anything like that, because the scale is gigantic. The weight of one of these tires alone is probably 100 pounds or something like that. With syringes, these are frightening. I don't like shots, and most people don't. You might hear on like a TV program the term like CC, 10 cc's, which CC is an abbreviation of cubic centa, and then if it's liquid, we're talking about liters. That looks like cienta. That's not right. We're not talking about Spanish right now. So this looks to be pretty precise, and you'd want to be if you're giving somebody a shot of some sort. And even here, like this is a drawing, but it looks like it's even more precise. There's like smaller intervals. This would be like, separated by, this is 70 and this is 80, and I see 1, 2, 3, 4, 5 spaces. This is counting by 2, and this looks to be counting by 1. So there's 10 here and there's 5 here. So this one looks to be even more precise than this syringe on the right-hand side. For these two rulers, you see that the centimeters, and although they look kind of different, we have 10 millimeters, which is the same as 1 centimeter. These are actually the same amount of precision, although they look different. This is 10 millimeter spaces, and this says 10 millimeter spaces. And for my last example, I kind of want to talk about these 4 different rulers. The one that is the most precise has the most little tick marks or spaces. The one that is the least precise has the least. And although these aren't to scale, I've ranked them. Least precise is at the top. It's at the top because it only has space for an inch. This is 1 inch, 2 inches. You can't talk about half inches here because you really can't measure it all that well. Here you could talk about half inches. Here you have half, and then you could talk about quarter inches. And last but not least, you could talk about half inches, quarter inches, eighth inches, and 16th inches, which is the most precise. Example number 1 says Jimothy is using a standard ruler to measure his height to see if he's tall enough for the Sickinator roller coaster at his local amusement park. Which is the unit of measurement to which he can expect to be accurate? Okay, I know that I'm talking about accuracy here, and I also know some other things. Standard ruler, I wonder what they mean by standard ruler. And tall enough. So we're talking about measuring the height of a person. Which is the unit of measurement to which he can expect to be accurate? You know, I'm going to think about this problem first. I think it's one of those situations where it's like, you must be this tall to ride the roller coaster. I remember when I was a kid, I have 2 younger brothers, and I have an older brother. So I was kind of in the middle, and I usually got the lay of the land because I have an older brother. And my younger brothers were kind of short. So they used to stuff socks in their shoes just for rides like this. So they could be 2 centimeters, 3 centimeters, 3 inches taller. And you know what? That's actually going to connect here. I mean, maybe you've done something similar. If I look at this, a person is only like 2 yards tall. I'm 6 feet tall, so this means a yard. That's not really what I'm talking about. It's not very accurate here if I'm talking about yards, because people are only like 1.5 or 2 yards tall. Sometimes if they're super tall, you're 2 and a 4th yard. Feet, well, you do talk about people being feet tall, like 6 feet tall or 5 feet 6, but if the sign says you must be this tall and it's going to be accurate, that means you would either be 3 feet or 4 feet. And that means there's nothing in between, because the most accurate you can be is whatever the measurement unit is. So that's actually going to be wrong. Now again, it gets down to millimeter and centimeter. I'm going to quickly draw something that's not going to be exactly to scale, but if this is 1 centimeter, which is usually described as like the width of a fingernail or something like that, it takes about 2 of them, maybe a little bit more to be a quarter. Maybe it's about a dime size. A millimeter, there are 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would be very, very surprised if at a roller coaster, when they're trying to measure how tall you are, they measure down to the millimeter, because that would have to be a super precise ruler. I would be surprised. Usually they don't even care too much. If you're close enough, they'll give you the benefit of the doubt. So when going between C and D, the answer is definitely going to be D, centimeter, because it gives you an accurate look at how tall you are, especially down to the wire when it's 3 feet and a centimeter, however many centimeters there are up to your height. Millimeter is going to be too close. So before I move on, in thinking about this skill, sometimes it's going to be too big, and like letter A and letter B. And sometimes I think this is actually too small. If I was measuring the height of a tiny little object, I would want to use a millimeter. If I was measuring the distance of a field, I would probably want to use a yard. If I'm measuring the height of a person with a roller coaster, I'm probably going to use a centimeter. Question number 2 says, which unit is the most precise to use to measure a runner's time in a 50-meter dash? So right now I'm talking about the word precise. And I should take precise to mean like exacting or accurate. So like it's going to give me the most or best information. And I'm talking about a 50-meter dash. And if I can remember, 50-meter dashes have to do with track and running. And this is going to have to do with speed. And speed I usually measure with time. So now I'm looking at my answer choices. If I didn't have these here, I'd think, well, okay, I know that if you run pretty fast, it's just going to be a matter of seconds that you get to the finish line in a 50-meter dash. If this was a 10K, or if this was a really long run, we wouldn't be talking about seconds. We'd be talking about hours. And if this was a mile you can run in a handful of minutes, faster or slower. So we're going to be talking about minutes there. So I think I'm narrowing my answer choices down already because I'm talking about seconds. When it gets down to the Olympics, you care about seconds for really long races, but for most people, they talk about how many minutes they ran a race in. But this 50-meter dash is different. That is a short distance. And if you want to help visualize that, it's about half of a football field, if you think about that. Half of one. So, the most precise is smallest. So I see 0.1 minute, which is 6 seconds. I see 0.1 second, which is 0.1 second, so it's hard to imagine, but that's very fast. 0.1 minute, so that is 1/100th of a minute. That's actually going to be pretty small, smaller than this one. So already I can get rid of A because C is more precise. And now it really gets into the 0.01 second. Well, this is going to be 1/100th of a second, and this is going to be 1/100th, so the same decimal, of a minute. In terms of precision, 1/100th of a second is more precise than 1/100th of a minute because this is the smallest amount that I can measure. This is actually quite small, very difficult to measure unless you have a stopwatch that is very accurate. So my answer choice is going to be D. Question number 3 says, given the spike that is being measured, must be talking about this thing, wouldn't want to step on that, the most appropriate unit to assign the value of this spike is... Okay, so what this question looks like it's asking is use the information given. So what are the limitations of the measurement device, and how big is this measurement device telling me the object is? The object is a spike, and let's see, it is measured by a centimeter ruler. I'm kind of thinking, I see it starts here, let's say that's at 0, that's 1 centimeter, 2 centimeters, and then it's a little under 2.5. So I'm talking about 2.5 centimeters. And if I think about my my knowledge of the units, it goes K, H, D, and then the base unit, or the unit B or U, K, H, D, D, C, M. Smallest being millimeter, and then biggest being the kilometer, and then let's think, hectometers don't really get used all that often, but that's like the second largest. And centimeter is the second smallest. So maybe you don't need to do this to answer the question, but it's good review anyway. Okay, so centimeter is what I have listed on the ruler, but I know that these little units that are broken up are broken up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these things, although this is a centimeter ruler, these are broken up into millimeters. The reason I know that is in the metric system, everything is divided into 10. So there's 1,000 grams in a kilogram. So I'm going to get rid of a couple of things. Appropriate unit, this would never be a kilometer. It's so tiny right there. It would never be a hectometer. Again, it's not very big. It's between millimeter and centimeter. I think the trick answer in this question is centimeter. Most people, if they were just to glance at it and not really think about this, would choose centimeter because that's what this is. It's saying, hey, pick me if you are not thinking about the answer. And then the millimeter is kind of hidden here with these little lines. Final answer here, millimeter. Which unit of measure provides the most accuracy? So it's like most exact, most precise, when determining time of a runner in a 100-meter race. So this kind of connects to example problem, I think it was number 2. So this is a race. It's a short race. It's not very long. In 100 meters, you're probably going to get that done. Not an hour. Minutes for sure. So that might be the answer. Second, 100. Oh, well, you know what? I'm not going to choose minutes. The reason I'm not going to choose minutes is you, if you're super fast, could get it done in under a minute maybe. But I want the most accuracy. So if I'm talking about Olympic runners, they're the ones who are going to be so fast that they're so close together. If I'm measuring down to the second, I'm probably not going to be accurate. My answer would be D, 100th of a second. For explain why your answer is correct, or why one of the other answers, I kind of explained why my answer is correct. I'm going to choose the second one. The reason hour is incorrect is because it would take far, far less than an hour to run 100 meters. It would take long, in general, if you're going to walk 100 meters, you'd get it done in a couple of minutes. So hour is wrong because it is far too big to describe the time it would take to run 100 meters. Number 5 says students are instructed to measure the capacity of a test tube. So test tube, I'm thinking about one of these little vials that has some liquid in it. And maybe it's, in the cc's or maybe it's in something else. To the nearest 100th of a liter. Okay, so it's actually not going to be in cc's. It's going to be in liters. Which method would best achieve this degree of accuracy? A, measuring the liquid required to fill to the nearest 1 milliliter. Same deal, nearest 10 milliliters. 1 milliliter and 10 milliliters. 10 milliliters is really a centiliter. Measuring the liquid required to the nearest 100 milliliters. 100 milliliters is not a centiliter, it is one above it, deciliter. And then nearest 1,000 milliliters. 1,000 milliliters is a liter. So this is kind of a trick question. It's asking, well, if I have the liters here, right? If that's your base unit, liters, centiliter, deciliter, liter, deciliter, centiliter, milliliter. Milliliter is 0.0001. 0.001. This is 0.01. This is easy to remember because it is a centiliter. There are 100 cents in a dollar. And decaliter is easy to remember because it starts with a D and there's 10 dimes in a dollar. That's the way I like to remember it. This answer would be hundredth of a liter would be a centiliter. Let's see what we have there. 1 milliliter, no. 10 milliliters is a centiliter. And so that would be answer choice B. Number 6 says, Evan, must be me, is calculating the area of a rectangular poster. So I've got that right here. Area is also going to be, length times width, and I would measure that with square units. That looks like a G. Should be a Q. Square units. There we go. He can measure the length and width of the poster to the nearest 1/10. 1/10 of a centimeter, cm. To what degree of accuracy? So I'm talking about how exact can Evan calculate the area of the poster? Here's a good question. If I'm talking about accuracy, The closest I can get is 1/10 of a centimeter. And if I break up a centimeter, this is 1 centimeter, not to scale. That's 1/10. That'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not great, but works. 1/10 of a centimeter is not a centimeter. It is 1 millimeter. So then I think this is where the answer is going to come through. Nearest 1/10 of a square centimeter, nearest 100th. Well, it wouldn't be 100th. Nearest 10 square centimeters. 10 square centimeters is actually not very accurate. So that's saying take a centimeter, multiply it by 10. That's not going to be good. Nearest square centimeter. Well, if it's nearest 1/10 of a centimeter, this would just be nearest 1/10 of a centimeter. For my answer to change, it would really mean that my description of the nearest ability of mine to measure, like nearest 1/10 of a centimeter, this section would need to change in any way to make my answer change. Question number 7 says Stefano's rain gauge is shown to the left. That's right here. I can tell quickly that it's talking about inches, and it's broken up 5, 4, 3, 2. So I'm not going to be able to measure too much rain. What is the greatest level? So the focus is greatest. I don't want to know the least. I want to know the greatest level of precision that can be attained with this gauge. The trick answer is probably inches, because that's what it says. It's like, hey, pick me, inches. Nope. You can actually get closer because it's broken up into little marks there. If there were no marks here and it was just something like this, here to here, the answer would be inches. But I'm broken up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right here, 1/10 of an inch. Why? Your answer should say something along the lines of, the measurement device listed is measuring in inches, but has tick marks or spacing that would display accuracy up to 1/10 of an inch, because there are 10 spaces between each inch that are delineated or lined up clearly. For number 8, the answer is 1/8, because that's the smallest. You see, this is half, fourth, eighth. If you would split eighths, again, it would be 16th, but that is not split, so the answer is 1/8. 9 is a little bit of a trick question. The table lists a lot of numbers that are, more precise because there's more decimals. But the answer is A, because the centimeter ruler doesn't have any breakdown or anything. You can't measure up to the millimeters or anything like that, because it's just a centimeter ruler with no spaces lined up or anything like that. When solving number 10, you do some math to find 9.5 times 34, because it's saying, 9.5 servings, 34 milligrams per serving. You do that math, you find that it's 323 milligrams of sodium, but the package said that there's 335. So first off, your answer is no. You can get rid of A and B. The reason I chose D is to find the amount of sodium per serving, you divide the total, so like whatever the total amount is, divided by the number of servings, which was 9.5, which I did the reverse of that and compared. But I think this is the better explanation than answer choice C.